Let's write an algorithm for how to multiply integers. In seventh graders, when I told you that you were going to be blown away by how simple the algorithms are for multiplying, I was not joking. Compared to when we were adding and subtracting and writing those really complicated algorithms, the algorithm for multiplying positive and negative numbers is super simple, super straightforward, and you're not going to have a hard time remembering it at all. Let's take a look at assignment 3.2, where you should have already come up with these answers, solving the equations in group 1, group 2, and group 3. First, we said that group 1 is special because all of these equations are multiplying positive times positive, positive 4 times positive 3. Group 2 is different because we have one positive number and one negative number, or in other words, just one negative and one positive. Group 3, though, is when we have negative times a negative, two negatives multiplied together. We're going to be solving these equations so we can find patterns in what happens to the products if it's in a group 1 equation, a group 2 equation, or a group 3. All right, let's take a look. So if we have positive 4 times positive 3, we know that equals positive 12. Positive 5.1 times 1 equals positive 5.1 still. And 3/4 times 1/2, positive 3/4 times positive 1/2, that equals positive 3/8. What did we notice about these three products? I noticed that when we are multiplying positive times positive, all three of the products are also positive. Okay, that seems straightforward. What about group 2, where we have one positive times one negative? 4 times negative 3, we found out that that equals negative 12. Negative 5.1 times 1 equals negative 5.1, and 3/4 times negative half equals negative 3/8. What do we notice about these three products? I notice that they're all negative. So when you multiply one positive times one negative, it'll give you a negative product. All right, let's go on to group 3, where we have negative times negative. Negative 4 times negative 3 equals positive 12, which seems a little funky, but we showed why that's true using the number line relay race. We also know that negative 5.1 times negative 1 equals positive 5.1, and the last one equals positive 3/8. What do we notice here about these three products? I notice that they're all positive, so negative times negative is going to give us a positive product. Let's write those down in part B in a way that we can use symbols so it's super simple just to remember. Remember, group 1 is positive times positive, gives us a positive product. Group 2 is positive times negative, gives us a negative. And group 3, negative times negative makes a positive product. Pretty straightforward, right? Let's try using these algorithms and maybe extending it so that you always know how to follow the rules to multiply integers. Let's start with negative 6 times 3. Well, I know this equation here belongs in group 2 because I've got one negative times one positive. Negative times positive, group 2, I know is going to give me a negative product. And I'm going to ask 6 times 3. 6 times 3 is 18. So negative 6 times positive 3 equals negative 18. What if we switched around and had 3 times negative 6? Well, first I'm going to ask myself, is that a group 1, group 2, or group 3 equation? I've got one positive, one negative, which means my product has to be a negative still. Okay, then 3 times 6 is 18. Let's pause right here. What do we notice about these two equations? Negative 6 times 3 and 3 times negative 6 flipped around, those both equal negative 18. So we could ask ourselves right now, is multiplication commutative? Remember, we found out that addition is commutative because we can switch around the order of numbers that we're adding and it'll still equal the same thing. We found that subtraction doesn't work like that. But is multiplication commutative? Can we switch the order and it'll still make the same thing? Yeah, we just showed that multiplication absolutely is commutative. Let's move on. What if we have negative 6 times negative 3? I know this belongs in group 3 because we've got negative times negative, meaning I know the answer will have to be positive. And I know 6 times 3, that still equals 18. All right, what if I have three numbers here? Negative 6 times positive 3 times negative 2. I'm going to go one step at a time, still following my algorithms. So I know negative 6 times 3, that equals negative 18. Then I'm going to think about negative 18 times negative 2. Negative times negative makes a positive. 18 times 2 is 30.